icebreaker before we kick off the session. I know you guys have wine glasses in your hands, so if you don't mind, actually you can put them down or something. Can all of you stand up and take out your smartphones? And all of you should have a stopwatch app on your phone. So any, phone, like your smart bands, whatever, can all of you just turn on your stopwatches? Like when I say 1, 2, 3, it's a very small exercise. I want you guys to turn on your stopwatches, take any path you want in this room, and come back to your seat again. Up to you. You want to come quick, you want to come slow, it really doesn't matter, right? So take whatever random path you want, do whatever you're comfortable with, but turn on the stopwatch, and when you come back to your seat again, turn off the stopwatch. I want you guys to keep a track of the time you've taken. So could we do this at my 1, 2, 3, yeah? Is everyone ready? Okay. 1, 2, 3. Okay, waiting for some more people to come back to their seats. Okay. All right, now you guys can sit down. I'll just call out for a few people to check how long you guys have taken. Anyone wants to say how long they've taken? Any first one? Okay. 70 seconds. Okay. Anyone else? 33? 40? How? 33.7? 20? 42. Okay. So why we made you guys do this unnecessary cardio is because this is ETA, right? What you guys were things on the road that are moving in a very, very finite space like this, super finite, right? You know how to come from one place to another. You've seen 5 different types of routes taken. You've seen 8 different types of time. You maybe bumped into each other. You maybe like got lost, whatever it is, right? You didn't know where to go. All of this is what drivers encounter day to day at a very, very, very large scale in a company like Gojek, right? And this is the reason why we are here today with, like the good folks from Gojek as well as us, NextBillion, to just talk about ETAs and talk about why ETAs are important and what's going on and how many issues happen and how we solve this problem at scale. So without further ado, I'd love to introduce the panel. Oh, wait, I need to get my questions. Sorry, guys. So without any further ado, so I'd love to introduce you guys to Nate, Germayne, and Gaurav. So guys would love to do a short intro about each other, and then we'll kick it off.
Hey, hi. Thanks everyone for taking the time to join us. So I'm Germayne. I'm currently leading a team of data scientists and data analysts in Gojek, where we are focusing on optimizing the routing capabilities from our mapping platform. And some of our day-to-day role involves conducting experimentations to understand the statistical impact on our key business metrics. We also maintain data pipelines and machine learning systems. And yeah, so that's all about me.
Hi guys, welcome. My name's Nate. I'm the head of product and head of business for Gojek's Maps team, and I can tell you a little bit more about Gojek and GoTo here in a little bit, but so I oversee our product development, our map operations, and our partnerships with a number of mapping technologies and data sources.
Thanks, Nate and Germayne. And Gaurav?
Hi everyone, I'm Gaurav. I'm one of the co-founders of NextBillion. Used to lead product for the Maps team at Grab, coincidentally, before this. And have been working on a variety of ETA and map style problems using machine learning and data science and engineering and whatnot So yeah, good to see a bunch of familiar faces in the audience. Good to reconnect. And yeah, looking forward to sharing more and hopefully interesting questions as well.
Awesome. Hi, I'm Ajay. I'm one of the co-founders with Gaurav as well of NextBillion. So yeah, I mean, I'd love to kick this off with a little bit about you, Nate. What do you do at Gojek exactly? I know you mentioned you lead product development and data sources. How did you come about this role, right? And a little bit about your journey and what you exactly do, so the audience get a bit of context.
Certainly, and for folks that I'm sort of assuming everyone that lives here knows what Gojek is. Gojek is part of a larger group called Go2. The Go2 group is an ecosystem for your daily life, right? So we provide everything across financial transactions to on-demand services to e-commerce across Indonesia, Singapore, and Vietnam. And so my role on the product side is leading our product team. Germayne and I work closely on our routes, but we also provide places and geocoding and location search APIs for across the Go2 group. We spend a lot of time on our on-demand services, given that location is a key component of that. And but yeah, so we'll get into a little more of that here shortly. But my journey, yeah, so I've been in maps from 10 years, over 10 years. Started in a garage in Washington D.C. Working alongside some of the founders of Mapbox, and that got me started in the mapping industry, and I've been sort of continuing to work in the mapping space. I've mostly worked in Africa and Asia on mapping problems, building mapping technology in more diverse environments, solving some tough challenges in those places. And so now I've landed at Gojek a few years ago and enjoyed it a lot. So.
Awesome, thanks, Nate. Actually, we'll get into a little bit of open source background and stuff a little later on. And Germayne, what about you?
So what's the question? Sorry.
Just a little bit more about you.
Right.
And what excites you about Gojek and why you're here?
Right. So I think as what Nate mentions, a lot of our focus, especially from the Gojek's perspective, is to make sure that we can give customer this experience that's seamless, that's accessible, and a lot of this is actually, done by, a mix of product, engineering, and data science. And where data science comes into this picture is that a lot of this complex problem, to a certain extent, has to have this balance between the engineering and data-driven methodology, right? And to a certain extent, once the complexity of the problem becomes really, really complex, it kind of makes sense for us to think about, hey, how can we leverage all these rich data sources that we have, based on millions of drivers and customers, and through this synergy, we can kind of create systems that are intelligent enough for us to scale, right? And that's actually this journey which me and my team actually started building in terms of routing, in terms of like, hey, how can we then get this accurate ETA which customers have a very high expectation of? And yeah, so that's
awesome.
Why it's exciting. Right?
Awesome, Germayne. Yeah, and actually we'll dig deep into the actual technical bits as well in our next section. And Gaurav, you?
Sure. So yeah, my background is I started my career as essentially a data scientist, but on Wall Street, where it's actually not called data scientist, it's more like quantitative analyst. Then sort of worked in product management for a while, did my own startup. This is my second one. Met Ajay and some folks here back at Grab to start NextBillion. And yeah, I mean, I work on everything product, figuring out how to use technology and location to help businesses, to help day-to-day users like us of these businesses. That's pretty much it.
Awesome. So, I mean, today the topic is ETAs, right? I know we did a very random experiment in person about ETAs, but actually, Nate, what does ETA mean inside Gojek, right? For you as a business problem, would love to expand on actually what does it mean for your business.
Yeah. Well, I mean, it's it's clear when you have an application where your map is a centerpiece of that. But map isn't just the only thing that is part of that experience, right? In Gojek, we have this kind of flywheel of customers, drivers, and merchants, right? When you think about on-demand services, you have all of these three users interacting. And across each of those components comes in some type of map component. Maybe it's ETA, where you are going to be picked up for your ride, or it's how long your food is going to be taken to deliver, or maybe it's a geocoding lookup and of a merchant. And so like across the entire go-to ecosystem, maps come into play, and location services come into play. ETA is a big component of that, and we can talk a little bit more about user experience of that, anxieties that maybe it creates for certain types of users, and so that's yeah.
So in your sort of 2-3 years in Gojek, right? Like, what's the best and the worst ETA experience you've seen? And what's your sort of holy grail when you want to define as a product person, this is my holy grail ETA experience, right? What's that in your mind?
A holy grail ETA experience.
What do you, I mean, if you were to define it to the audience here?
One is like, it kind of depends on the location. So we'll talk about a little bit like where we've run focus groups and across all of our countries. And what are the user expectations? That varies in Singapore versus Indonesia, and so that experience needs to meet those expectations. Most of that is around accuracy of information and being able to clearly trust the information that you see. So our holy grail experience is about getting that right, accurate information that is timely, that it's up to date, and one that you can consistently trust. When one was not, you have changing. Yesterday's ride. You expected a 5-minute ETA, and today you got 10 minutes, right? And so there's more of a consistency and reliability of that, and that's a key thing that we're focused on.
And this takes me to the next one, Germayne. Right? On a technical perspective, right? How are you guys working on solving it? I mean, what do you guys do? And any sort of knowledge, I think, will be good on how you actually solve it technically.
Right. That's really a really great question. So I think I'll just set like a bit of context. So getting ETA right is not just simply, have a bunch of data scientists and then, curating some sort of historical data and then just jumping right into it by building a machine learning model, right? There's much more nuances that really goes beyond just the model building when you kind of think about ETA. So, one way of formulating this would be we kind of approach this from, building multiple parallel, multiple building blocks, right? And at the really base fundamental of ETA itself is actually the map. Because if the map itself is not correct, if the road network data that the company is maintaining is not, it doesn't reflect what reality actually is, then, even if you have like a model on top of it, the ETA itself will never be as accurate, right? So at the first fundamental level, you have to understand that you need to ensure that you have this map data. And map data itself has its challenges because the world is dynamic. What you have is a snapshot at a certain point in time. Then it goes to, the next question will be then, how can we then intelligently ensure that the map data is up to date, right? And, beyond the map data, the next question to answer then would be, how can we then have a routing capability that consumes this map data, right? I think we did the exercise and we saw that, there's a few different permutations of getting from a given origin to a given destination. And, if you kind of think about it, if some of you are driving, you would have this experience that, hey, I don't think this is like the route that is efficient. And then, the question to be asking would be then, how do we then define what is efficient? Maybe everybody has a different subjective definition of that, right? So, thinking about it from the routing side, thinking about it from the map side, and that's when, once we get these two components right, we then also need to know about, hey, can we then accurately predict when will there be a traffic jam, right? And we kind of know that maybe there's a peak period at 9 a.m. or 6 p.m. when people are leaving, and that could differ between countries, right? And with these 3 building blocks done, that's where you can start thinking, hey, can we then think of something intelligent to gel them together? And that's where the intelligent part of machine learning comes into play. So
Yeah, and this extrapolated over the scale of millions of rides every minute almost, or in every day, right? I think it's a very, very challenging technical problem. Again, we can talk a little bit in depth about that. Actually, me and Gaurav have worked on it quite a bit, so I'd love to get Gaurav's perspective also on his experience with all of, Ola, Grab, and now NextBillion, what you've done.
I think Nate and Germayne have touched upon different points. Maybe I'll touch upon a different one, which is something that was very interesting to me is while some of it, like the technical person in me thinks, it's a very cool, interesting technology problem to solve, which is very complex, very multidisciplinary, and coming from sort of computer science academic background, and I know there are some students here in the audience as well, it was very appealing. But what was even more interesting is at companies like Grab and Ola and Gojek, this drives a ton of business impact in terms of, you can feel it as a customer that your rides are more accurate, customers are happier, drivers spend less time in traffic, they have to travel less to get to their next rider, they earn more money. So I think to me this was the most interesting aspect, where it's one of the few areas I've found where it's a great intersection of something that's very important for companies, something that drives a lot of business impact, but it's also very sort of technically satisfying to work on these problems.
Yeah, I think also what we've seen from our past is it's more a network efficiency problem than just ETA. Better ETAs give you better rides, better allocation, better batching, better fares. So it's a full network optimization, and even at a Grab, Gojek's, Ola scale, 1% is a couple of $1 million a day. So that's essentially how important ETA is. Just a subset of a really, really large problem, I assume. It's just one component. So with that, right? So you're back to Germayne. So could you explain the nuances? Like you're a super app, your food, logistics, parcels, and ride hailing, and you also have a merchant network. How is it different? How are the technical challenges for each one of these different at high level? How do you guys go about solving them?
Right. Right. So there are certain nuances with what you shared, and I think one of our key focus area at the start was actually focusing the pickup experience at the start, right? Because as a customer, maybe at a customer-facing ETA, you have this kind of anxiety and expectation, right? If you see that a car will be coming in 5 minutes, if you are at a comfort level in your apartment, you would really expect the car to be at 5 minutes and not come like at 10 minutes, right? You feel like you committed 5 minutes and hey, I still have to wait like an additional 5 minutes for that. So that's the key area from a business where we really want to get that aspect right? So we started focusing on getting the pickup experience right. And one of the area that we actually have some additional challenge is that, let's say, for example, in the pooling example, right? When you think about pooling, the driver itself is actually on the way to fetch you, but they have to drop off a customer prior to picking you up. And this actually adds in this element of uncertainty, right? It's not as simple as from a distance perspective, the driver is just coming to pick you up, because now you have this additional uncertainty of a prior passenger being in the car, and there might be certain increase in uncertainty in timing for the driver to actually drop the customer. And then that's actually where we start to also invest in some time rethinking how can we actually formulate the problem in a much more general and scalable manner in order to solve this experience.
Interesting. Yeah. And back to Gaurav, right? So in sort of our experience as well as in NextBillion and Grab, how are you looking at this problem? Because we've seen that, for example, in food, it's very different because driver has to go wait, and food shouldn't get cold. That's what you're optimizing for rather than time to food, right? So how do you think that core map technology can solve some of these problems?
Yeah, and so what I find interesting is while at high level everything feels like, hey, how much time is it going to take from point A to point B? Each of these businesses tend to be very different. Like in case of food, we have this phrase of kitchen to couch, where you're looking to figure out how much time is the food going to take to prepare. The driver has to probably park his vehicle, walk, wait at the restaurant while the food is getting prepared, then walk back to his vehicle, park the car, then sort of walk and deliver. This is different from ride hailing. This is also again different from grocery delivery, because in a grocery scenario, probably the driver is going to a store, getting everything together, but then has to optimize other things like, hey, this order has to be delivered last, so I should put this at the back of my vehicle, not at the front, so that it's, the stuff that needs to be delivered should get loaded at the end, last in, first out, sort of an idea. And each of this involves, again, moving things from point A to point B. And yeah, again, our experience is that if you do all this well, this is all stuff that happens in the background, but again, it's tremendously helpful if you do it right for customers, for businesses and everything.
And then, this brings me to Nate, right? So, what are these unique cases, Nate, that you have seen, through this, all of your 10 years in mapping world as now in Gojek, right, that you've had to solve? That there are certain things that we have had to solve that's very specific to your business. So, what are some of the unique things combining the technical challenges that are there for the number of applications we have in a businessy product sense? Anything that you can share?
Yeah, I mean, well, Germayne talked a little bit about this, the uniqueness around kind of the difference between a pickup and a trip ETA, and there's a different length and distance that you have to estimate and predict. I think when we look at the pandemic, that changed a lot of patterns, behaviors of people, how they travel to the office or don't travel to the office, where they get picked up at. I think you have, what we saw in Jakarta was that there were a lot, like, neighborhoods had a lot more lockdowns, right? And more neighborhood level lockdown. In Jakarta, there's a lot of neighborhoods that have lift gates. They might have multiple entrances to the neighborhood, but they lock one to kind of prevent more and restrict access. So traffic patterns and way people move around the city drastically changed. So modeling that got tough, right? And looking at historical traffic got tough. So like, these are unique things that happened over the last 2 years, and that we had to account for and build something that is able to account for that.
And this brings me nicely to this subject as well, right? So two things we're here to discuss is AI and hyperlocal, which we've still not touched upon. So this is a segue into how is AI in the middle of all. It's a great buzzword, but how are you applying this scale of AI into your real business problems? And what do you mean by hyperlocal nuance in data science, right? So would love to just know a little more about that.
Okay, so I would break this into several points. So I think something that's really relevant, maybe across industries, is that most businesses would typically have this cold start problem, in a certain sense that you would want to start to build something that's intelligent, but then you do not have the data required, right? And this becomes kind of like a chicken and egg problem. And you really want to start thinking about building heuristical systems has a baseline first, and then that's where you start to have something that kind of works. Maybe it's not really perfect, and in the meantime, you start collecting data, understanding what's the pattern trends, and then in the next iteration, you start to incorporate this data into your system in order to now have something that is, there's this closed feedback loop in improving the system itself, right? And to a certain level, for a very complex problem, I was speaking to some of you guys, and at a certain, to a certain level, when the problem is really complex, you have to move beyond baseline heuristic systems, right? You kind of have to incorporate many dynamic changes, many input variables, and you have to include like many sources of data, structured, unstructured, and that's where you have to really leverage machine learning techniques, right? So that's really the first point that I want to bring about. And I think the second point with regards to the business is that we really want to work efficiently, right? To work at scale, you could either throw money at the problem by hiring a ton of people to do the manual work, and especially for the mapping space, a lot of changes, curation really kind of require this level of manual intervention. But then I think what we can really leverage machine learning in this case is that, hey, we can then, instead of throwing 10 people to solve the problem, maybe you just need half the number of people with machine learning, right? Yeah.
Absolutely. So I think Gaurav, the next question for you, right? So in our own experience, we've seen it's just not a machine learning data science problem. There is a bunch of manual curation always required, bunch of tooling required. It's just not a very linear problem. So hyperlocal plus AI, how do you see it solving the problem? We've done some work in POIs, some in road. So anything for the audience?
Yeah, so I think, again, location technology, and now like anything location is somewhat unique, I guess, in this way that, it interacts, it's technology interacting with the real world. So things that are happening in your neighborhood, or like the example Nate mentioned, that this apartment, these entry gates, Jakarta versus Surabaya customer expectations, or like Singapore versus Jakarta, right? Completely different. Where sort of this idea, that's sort of the hyper local idea where each local spot or region behaves differently, and how can you incorporate those aspects? And at least our experiences, machine learning, etc., is a great way to infer or draw some of these inferences. But then there's also this human aspect of this, which is like, this is very much something that affects our day-to-day lives, right? So I believe tools, etc., are also super important, which is, how can you get people who may be familiar, maybe local teams, because somebody sitting in Singapore will not necessarily know what's the right thing for a small city in Indonesia or Vietnam for that matter. So this is where I guess all this like tools and human beings and local knowledge, machine learning, all of that sort of comes together.
So in our world, we call it assisted intelligence, not artificial. It's because it's purely not artificial always in maps. So this brings me again to Nate, right? So Nate, you've been in the open source, crowdsourced, and all of these backgrounds for a while, and there is no bigger weapon, according to me, than that for us to leverage. So there's a bunch of AI, there's a bunch of assisted AI. How do we leverage crowd? How do we, just talk about incorporating open source stuff into this, especially in our world, OSM? How have you seen this evolve over the last couple of years?
The evolution of OSM and the evolution of like open source
and
data,
hyperlocal, how people in their own communities edit their own maps, So
Right.
I think a lot of people may or may not be aware about the scale at which this is going on. So
Right.
I think it'll be a good discussion to have on even that.
Yeah, I mean the hyperlocal component of that is a key part of localized maps, right? And that localized experience. Another example of like this hyperlocal is not just like lift gates in Jakarta, but condo entrances and the internal roads to get picked up at your lobby, right? Or at a mall. It takes time to enter in through a parking gate. It takes time, and so having the ability to have that fine-grained data about that then allows us to incorporate that into models and get better at ETAs, right? To better model that. So I think on the open source side of things, like a key thing is not about free or low cost. It's about like this ability to have flexibility and like to have customization. You have the ability to kind of tailor the data, tailor that experience and how you use that data to how you want to integrate that into an ETA engine or display it to customers, and so like the journey that we've seen and is that is a key component in really building out location services and ETA services that are accurate and that customers can trust.
I mean, it's the same thing, right? Like you'll call it footpath, and somebody's going to call it sidewalk. Standardization of data sets, understanding everything at a data layer, especially in a mapping schema, is a very difficult, actually, engineering problem, even than a data science problem. So I know you've spoken a bunch about ETA, AI, hyperlocal. I would love to take any questions from the audience. Like, again, we really would want this to be interactive. Just I would love to know if any of you have any questions for us or Gojek. Would be happy to answer.
I have a question for Mr. Germayne. So about the machine learning model. So as you mentioned, the Gojek is operating in a lot of countries in Southeast Asia, and also different city of those countries, like urban region or small countryside cities. So I believe those are very different. So like in Vietnam, we have tons of motorcycles on the street, and in Singapore everything is organized. But in Jakarta, it's like the drivers may not be following the traffic rules so well. So when you are, I believe that you are trying to build machine learning model to take all these factors into account. So my question is, are you going to build one big, large, super smart, centralized AI model? Or are you going to build separate models for separate countries, or even smaller, different model for different city? So which one you think is more, it's easier, or it's more accurate to build?
Yeah, this is really a great question. Okay, I'll probably share like our success with it. So right now, what we have seen is that we actually, we operate throughout Indonesia, and what we have actually seen is that if you build your way that it's able to generalize the patterns, you can actually have success cases of inferring cases where the model has not seen. So a really good example is that currently right now for Indonesia, for example, we train the model using a large number of data on some of the major cities, and we actually roll the ETA model out across the whole of Indonesia. And there are actually cases where we don't really specifically train on a particular smaller city, but we can see that the ETA itself is still really accurate. And based on some of our early experimental stages, we could even see that our Indonesia model, to a certain extent, able to get, let's say, Singapore right? But I think there are certain nuances, like what you are saying, in terms of the underlying road network, which lead us to create like a separate model for Singapore. But I think end of the day, it's a balance between design decision and maintenance, right? You probably can solve this problem by having individual models for each city. But then if you think about in terms of scale and in terms of maintenance, that becomes crazy, right? Machine learning model doesn't just end when you deploy to production. The data science team and the engineering team has to ensure that the SLA itself, the accuracy that we are providing to, especially then if you think about, like providing it to other downstream teams, it's not just, you accountable, right? If something goes wrong, you affect the entire network effect of the services. So then does it make sense for you to have like 10 models for 10 cities, right? So then it depends on how you design it. And we have seen success in creating a country level model, and you can also get, the model itself can also leverage certain patterns across the cities itself. Yeah, so hopefully I answer your question.
Yeah, thank you.
This question to Germayne. This is regarding, you spoke about some heuristic, right? Yeah. The heuristic. So I was wondering, how the basic heuristic has been determined, and along the way from kitchen to couch, I mean, how the process of heuristic is going to update by itself, or Thank you.
Okay, I think that it really depends on the context, but maybe I could share like an example based on like the conversations that we are having today. So for example, if you think about a point, an origin and a destination, you could either get something, you can get like the Haversine straight line distance, right, from point A to point B, or you could get the actual route distance. Maybe at the start, if you do not have a complex routing capability, then maybe something you could start with is just a straight line from point A to point B, right? it kind of proxy the distance between 2 points, right? And then once you have the capability, you start thinking, oh, you know, I can now get a bunch of rank routes, maybe the fastest, the shortest, right? Or the fastest, shortest, right? So I think that's the example that I'm driving at. So really depends on like, you know, the complexity of the problem itself. It doesn't have to start with machine learning. It could be like certain heuristics that you could build using statistics itself, right? It doesn't have to be a model. It could be just purely statistical computation.
The base distance can also be a heuristic in the starting phases, right?
Yeah, yeah. So that's what I kind of meant. Yeah.
Thank you. And the second question could maybe Ajay or Gaurav. This is regarding the triangle. If you see the kitchen, couch, and the travel, right? Given a case of kitchen and couch are determined, they're fixed. It's been decided that they're fixed. And does it make the problem easier, you know, to make the other ETA solving? Yeah.
You could say so, but then in that kitchen to couch problem, there are various other things that are extremely out of control. Where, for example, how much time is a restaurant going to take to prepare, like, you know, this one dish versus these two dishes versus these three specific dishes, but that one has a specific request of additional sauce on the side. And then should the driver go and wait there, or you will anticipate that this food will probably take 20 minutes, so I'm going to send the driver after 10 minutes. But what if you send the driver late and then the food is ready and the food gets cold? So you're going to complain to Gojek saying that, hey, my food is cold, right? So it's you could think it's easier in some ways, but in reality, each of this adds a ton of its own complexity.
Because this idea, I'm thinking about the bidding process. For example, the customer has made a bid to the restaurant. They both have agreed that it will be delivered after 3 hours. That has been decided. Okay? And because of the ETA.
That's a different problem statement than the real-time one where
Yeah.
order the food and you want it.
Yeah.
Yeah, it's two. It's either windowed or real time. Windowed is a completely different problem.
Okay.
If it is real time, it's a very different problem. It's because many times drivers actually go and wait and they don't start making food also. There's a handshake between the driver and the restaurant that I'm going to make the food, you pick it up. Because cancellations are very high, apparently, in this business, right? They allocate a food order, they go and a driver doesn't even reach the restaurant cooks the food and keeps it ready. So all sorts of nuances are there. So there's no singular answer, I think, to this problem. But if you're talking about windowed, it's a very different model, very different approach to it.
And okay, does it make the problem easier? Or
Relatively, I think. I mean, windowed is always better than real time.
yeah.
You then have to be more innovative in other ways. So,
Thank you. Thank you very much.
Hi, this is a general question for the panel. I actually have, this question has two parts. The first part is, how does one quantify the business impact of, let's say, an incorrect ETA estimation? For example, perhaps if you overestimate it, perhaps customers are unhappy. But if you underestimate it slightly, perhaps the customers are okay. Right? So that's the first part of the question. Second part would be, is this somehow incorporated into the prediction model? You know, for example, by modifying the loss function. So instead of trying to predict the timing accurately, perhaps we try to predict the timing in a way that would minimize the customer dissatisfaction. I hope that makes sense. So is there any of that in your?
Is it for me actually? Okay, so the first one is more of like the differences in terms of expectation, right? I think one way, so I think this is more of the business side. So I think like what Nate mentioned, we actually had this focus group study, which we kind of try to understand, hey, what's this expectation? Because expectation is not something that you could derive directly from data. From the map perspective, we could really just measure, hey, you know, how accurate and what is actually our error, right? To a certain extent. So we kind of have the focus group discussion, and that's where we kind of tie in the impact of the ETA accuracy with what is expected from the customer, right? So that's done through the focus group. I think the second way, the second question that you're kind of asking is, hey, how can we then incorporate like expectation to the model? I think this is slightly more complex. I don't think we could really optimize expectation directly. Maybe expectation have to be redefined in a certain way, right? We then have to define what is this expectation. Is it like booking rate, or is it like revenue, etc., right? And usually this function itself is not really, depending on your model, if it's not differentiable, I don't think you could do it directly. So there's always a gap between the online business metric that you want to optimize versus in reality what you could optimize from a technical model perspective. And then I think I'll just end with yes. I think really depends on how the business see it. If you want if you feel that between overestimation and underestimation, there is so we call this asymmetric, right? If you feel like there's a need to incorporate this asymmetric expectation to the model, then yes, that's probably one way you could do it, is through modifying the loss function. Yeah.
And specifically on the quantification, there are also some things you can do. So this core ETA, this applies in many contexts. So as an example, it applies in pricing. So the price that you see is based on some estimation of how long is this trip gonna take, or how long will this delivery take. So there are different things you can say there. Like as an example, one simple way to quantify heuristical way might be to say, at the end of the trip, this was the actual trip time. We predicted this fare, therefore we under predicted. So you add under predictions, like the absolute value of under predictions as well as over predictions. And you say this is as an example, impact of inaccuracy of my distance time estimates on pricing. That's one example. Now let's say you wanted to track the impact on dispatch. So you would say, okay, I'm gonna roll out a different ETA model that's, let's say, more accurate, and I'm going to run some A/B test. And then I will see which one has lower cancellations. And that's another way to quantify impact, etc. So you can use some of this as well.
I have more like maybe a business question, not sure to Gaurav or to you guys. It's more about like how do you quantify the value of the ETA? What is actually the business value? For example, I'm coming from China where the discussion is like the platforms like Ele.me or Meituan. I think the main discussion is about the fact that the drivers are getting compensated based by the delivery, and if they are late, they will be basically penalized somehow, right? Because the fee is always by delivery. I mean, I assume you not employ drivers directly, but you work with some staffing agencies who then basically pay the drivers by stop, right? And what happens, for example, in China is not like the customer satisfaction is that important. I mean, you already paid for a dish, you order from this restaurant. Of course, in long term, it is important, but people will understand, okay, today is raining, so obviously we can expect there will be delays. And if my food is like delayed 5 minutes, I will not freak out, right? But what of course matters is the drivers, right? They make less stops, they make less income. But I wonder how does that, impact you in Gojek, for example, if you can, squeeze more stops, or if the driver is really late by a couple of minutes, what's the value of this ETA?
Let me make sure I understand the question. Like the overall value of ETA and getting it right? So in the business impact on that.
Right. If, for example, your calculations are really accurate, you really can penalize the drivers
why
for
is that
being
good?
on time, or you can have this discussion that the ETAs were far too aggressive and they were just used to maybe, I don't know. Let's say that there's a frictions with the riders, for example, right?
Yeah.
How do you optimize that?
So what I would say is, like, one way we look at this is dependent on the use case, kind of where it comes in. When you look at a ride-hailing order, impact of ETA is very much the kind of the cancellations or the return, whether I'm going to be a return user, right? So if I get it correct, all right, I trust this, right? I can trust that when I order something, and that might be dependent and vary by users or by the customer. Maybe in the mornings you're wanting to go to work, and so you need to have, and you're running behind, and you want a driver to be there in 5 minutes, not 10 minutes. So I think that's a big impact. On the food side of things, the impact on kind of correct allocation. So when what Gaurav was talking about earlier around timing of the driver to get to the restaurant is a big deal. It matters whether the driver is waiting there 20 minutes or 5 minutes. That getting that ETA correct.
How does it matter? For example, I mean, in a sense, if the driver is paid, for example, by job, does it really matter that much to you, or you really pay them like a daily rate or something like that?
Yeah.
Therefore, it really matters for you to squeeze more stops.
No, I think it matters to them as like when they are operating on a number of trips, right, and number of orders, and so being able to respect the driver's time, things like a waiting fee, for example, right, honoring drivers, equipping drivers, and I think we care very much about how we treat drivers, right, and so getting the ETA right matters in that situation, and so we do care and want to optimize for that, so that drivers do feel respected and that they can do their job and continue to take the next order and do that efficiently.
I'll just add 2-3 more points from our prior experience as well. So if you keep the driver more engaged on the network, they earn more. That is first things first. So, and for you to keep the driver more engaged, what I was discussing prior, it is a cycle of ETA, allocation, batching, everything, right? All of this improves with ETA. Because if you can predict that the next ride is going to end in 2 minutes or 3 minutes, and you can allocate the next ride, if it's ending in 10 minutes, they lose the ride that you allocate. So that's essentially how it improves. It all comes down to their earnings, actually, on the driver side. On the consumer side is better allocation. So if you see many times you don't get a cab. That's largely because the ETAs are not getting predicted correct, that somebody around you is going to end the ride in a quicker or a later fashion. So there are two impacts there, and there's obviously much more on the business. But if you can, from what I know, I think 40-50% of the drivers they don't have jobs all the time, right? If you can improve that even by 1% or 2% of them having jobs, throughout the network you make more money. So that's why it is very crucial.
Yeah, so I kind of think that maybe from the mapping team perspective, we kind of think of this as trying to model the signal as accurately as possible. So there are some nuances like that was mentioned in terms of like how allocation was done. So those, we have like other teams that really focus on those problems. And on our end, we are just focused on getting the routes right, getting the ETA right. We satisfy the customers, and when everything else just fits, and if we model it correctly, systems becomes more optimal, and then naturally you'll start to see that everybody is happy, right? And that's the whole point, I think, of us using technology to aid in optimizing like the whole experience for both the user in terms of the drivers and the customer's perspective. So yeah, just to add that on.
Hi guys, we talked about humanizing AI. We also talked about driver retention, which is an important function of business success for Gojek. The question that I got is, a lot of ride-sharing companies or ride-hailing companies are using distance as one of the main metrics in their model for costing the price of the ride. When we talk about humanizing ride-sharing or ride-hailing or point-to-point navigations, for example, one factor is the inconvenience to the drivers when it comes to certain distances or certain jobs that they are carrying out. The question is Gojek using anything else other than metric in order to price its ride? How is it leveraging on that humanizing aspect to make sure that drivers are adequately compensated for their inconvenience, especially in situations where traffic jams, certain inconveniences, high peak hours, for example, occur out of the expected?
Yeah, great question. I think on the map side, we have what Germayne was saying was like really focused on providing that data to get accurate pricing, and so I think where we have been focused on is providing drivers with that right information, like not only just like location, being able to carry out that job, but like expected time, the time that it's going to take for the trip. So I think that's where we have been focused on providing the right information and accurate information for drivers in that expected trip. That comes into the pricing side of things, and so providing the right information for that correct pricing. So I think that is where we have been focused on as a mapping team, and so I think that's where we've been providing the right information on the pricing side.
I'll add a couple of points to this. So again, going back to your point, right? One of the key things drivers care about end of the day is earnings. Now, to your point, if there's a lot of traffic, if you're using just distance, maybe that's not getting incorporated. That also talks about why some of this work on maps is important. So a big reason why people don't incorporate time is because it's too variable. Now, if you're more accurate, you can price on time. But that's extremely contingent on your ability to predict time well. Now, if you do it accurately, then drivers feel happier. They feel like, hey, you know what? My time and my inconvenience is actually translating into appropriate levels of income. So as an example, there's like, again, putting a metric to it, you can look at the standard deviation of earnings per hour at different times, etc., etc. And if you can reduce that standard deviation, that gives drivers a much more consistent experience on the platform, which then in turn leads to higher retention, etc., etc. So yeah, I mean, all this you can incorporate. I mean, there may very well be other aspects that, hey, I don't like to go in this neighborhood, but at least some of these like human aspects you can definitely incorporate.
Hi. Sorry. So in countries like Indonesia, where there's like a month, where in Bali specifically, like sudden road closure or something, and it will affect the ETA. Like how do you like train the models? Like, do you work with local authorities, or because it only happens once in a while?
Right. Okay. So I think from my understanding of your question is more of like, how can we account for road closure, right?
Yes, on specific like sudden road closure, or like even like once in a month, that we know that in Bali there is always like this Hindu festival. So there's some small gates gonna be closed, and it affects it most of the time is the cars.
Right. Okay. So I think if we localize this context, we could probably think about the recent F1 event. So for example, in the recent F1 event, there are certain level of road closure, right? So we don't really need to approach it from immediately at the model standpoint, because ultimately, end of the day, you start with the routes, right? Then you think about ETA. So if your routes itself can already handle this road closure, then your model automatically is handle this. Does that answer your question?
Okay, kind of. Thank you.
So I think me and Gaurav were laughing because we spent some time in Bali exactly solving this problem. No complaints though. See, you need a few things to solve this problem. A, you need a tooling system inside your own to even understand these road network closures. Then yes, you have to work with the local authorities to understand when they're closing it and why. For that, you need hyper-local knowledge. There is no way you can sit anywhere in the world and understand what's going on in Bali, because A, the government will not put everything out there, so you need to know. Third, you need to apply this human-assisted intelligence we spoke about, plus AI. So you need to route, but for you to understand the routing graph, your map data has to be precise. So you need to apply a restriction, put the restriction in the route model, then generate a new route, and then do ETA. So and F1 is a classic example of how you can solve it in Singapore. It's just not Bali, it's just not Singapore. This happens world over. Every city has issues every day, just not festivals. So this is the reason why we started NextBillion actually, because there is no company in the world today that gives you a platform to open close roads. Is a very simple example. I'll give you 500 other things, right? There's hazmat. Like if you are transporting biochemical waste that can't go through residential areas. There are trucks that can't enter by lanes. So it goes on and on and on, and each one of this actually requires a specific nuance to apply. For that, you need a tool system inside. It is not an AI problem. It is AI plus manual plus knowledge plus all of that problem. That's why maps are so complicated.
Yeah, if I can add, like a key component there is a feedback loop, right? And being able to detect whether that's an automated feedback loop or a manual one where there are a driver submission or some type of direct feedback saying, hey, there is a change, right? And so having the ability to have that feedback loop is critical in detecting these small changes or the big changes that are planned. And I would say also, like, just to kind of go back to this open source, open data component, is like having partnerships with data sources that allow you to have some of that quick change, you know, and I think that's where this problem can be solved through that kind of multi-channel effort.
In like a marketplace where you have drivers, customers, it's easy to take feedback as well. You can also automatically take a lot of feedback, like very simple thing. If your cars are stopping in a specific point every day, a quantum, you can easily machine learn that to say that is a stop point. It's simple when I say it, but it's I think everyone's done it, right? With that, you can actually create like millions of synthetic points. You don't need POIs for it. You can just create points where every day pickups and drop-offs are happening. It's a pretty simple problem to solve. So like that, there are many things once you have a network already of customers and drivers, but it does not solve the problem you mentioned, right? For that, you require the whole ecosystem of things. Great. Okay, anything else? I was not supposed to answer questions. I'm sorry. I'm just supposed to moderate the panel. So, okay. I think this brings us to the last segment, right? I mean, so I just love for each one of you guys to talk about like a career experiences in just a minute or two. Like, how did you come to where you are today? And what excites you every day? Why maps? All of us love maps. It's a very niche subject though. So, yeah, I would love to know why you guys are here and, you know, just explain a career journey a little bit.
Well, I came here to have a drink. No, look, my journey started actually in grad school in rural Kenya, studying malaria. So I have a public health background, and one of the biggest challenges that I had when I was there was like this access to data and tools to be able to equip local public health providers with information and analysis, and like that excited me, like with this blend of location and open source and the ability to equip anyone with the right map and the right information. That got me into maps 12 years ago, right? And so that journey is what continues to excite me, where I've been enjoying taking on new challenges from small nonprofits to now a large national public company, and where we're solving some of those same challenges of providing the information, providing a map, accurate map data, and doing it in using some open source tools, building open source tools, and that's what excites me every day, and kind of the job that the team that I get to work with.
Okay, so I probably share how I got into data science. I would say my undergrad started with mathematics and economics, and actually my first experience with kind of data-centric analysis and impact is actually under this field of econometrics. So from an economic standpoint, you would want to understand and reason on macro level policies on certain metric like maybe GDP and stuff. So that's actually where you start to apply sort of like econometric statistical analysis on certain data, panel data impact, right? And that's actually where I start to see that there's actually this interesting application of data and maybe like the hard sciences to be able to have like impact to society or a certain level of value. And I think, you know, as I advanced through my careers, I was solving data science problems in, you know, various different fields, you know, through the healthcare industry. And I think by chance, I kind of got into the cartography team. And you know, it's kind of exciting because if you think of maps, there are actually many applications of, you know, the multidiscipline or field of study that could be applied on maps itself. Maps could be a, you know, an image problem, you know, vision problem, you know, it could be like a graph, computer science graph problem, you know, or it could be like, you know, a standard machine learning problem. And you know, there's really a lot of application that we could kind of apply to soft maps. So it's kind of exciting because there isn't like a single mundane kind of field that is just analyzing geospatial data, right? There's really many ways you could approach the problem. So yeah, so that's where I am.
Yeah, so I think maybe I can share more about experience of like sort of coming from a technology background and then doing a startup as a founder. So I mean, what I like my background, so you know, pretty early on since my first job, it was about using math, applied math and computer science to sort of real world problems. So I started on Wall Street, you know, doing this for stocks and derivatives and whatnot. And then moved into technology, was doing sort of product management. And then what I like about the current thing that we are doing is, like, maps is a very interesting multidisciplinary problem as we've discussed today. But also, you know, as a founder, you have an opportunity to help various businesses around the world. So, you know, see how technology and your software experience can help other companies build something for them, which in turn helps, you know, other day-to-day consumers like you and me. So yeah, I mean, seeing that, bringing that to life from something, you know, from starting from nothing is pretty cool.
Awesome. So I have the most boring background, so I'm not going to give mine. But why I am here today is because I was in Google Maps for a while. And how many of you guys have used CAPTCHAs on your screens on computers? So when I was at Google bought CAPTCHA, and they started putting street view imageries to annotate CAPTCHAs, and per day we were doing 500 million annotations for free, just by asking people to click. And I'm like, that is a scale of problem that you sort of want to solve when you go out there. And it was huge, and the amount of free data we were getting from that was amazing. So yeah, this is why I'm in maps. So yes, with that, thank you so much for this. Please have some wine and sushi, and a big round of applause for everyone here.